Who was it Tara and Ben? I'm not sure. But thank you. So I have a side computer that I look at. It's my school laptop, actually. Okay, so let's look at this function. What type of function is it? And what type of that function is it? It is a rational function. It has x in the denominator. Remember what we did on the first day of classes? We looked at the rational functions, right? Rational equations. What type of rational? Because now we know we have. Do we have only 3 types? No, I don't want to give you the wrong impression. But in algebra, we should not really look at more than 3. Because we don't have the tools. We don't have enough tools to study other types of rational functions. We're just going to punch in the calculator because we can't discover anything by hand. Okay, so it's rational. And which type? We have 3 types that we are going to talk about. Is it type 1, type 2, or type 3?
2.
Yes, it is type 2. Higher degree in the denominator. Very good. Excellent. We start the same way, and now you know that this problem will take 3 minutes. The first one took 30. I'm exaggerating. Okay, I need a domain, so I can fill up the chart starting with a domain.
Negative infinity to 2, 2 to infinity.
Excellent. Oh, I forgot. Sorry. Let's go back to the previous problem. Sorry. Okay. In y equals, clear if you have anything. We have to put in this function. And remember, in the graphing calculator, we have to have parentheses around the numerator and parentheses around the denominator. Don't forget that, because the calculator will not do what we wanted it to do. So parentheses x plus 1. Slow me down or make me stop or whatever if you need more time, please. Over x minus 1. Can you see? Is this clear?
Yes.
And please, the calculator doesn't know that there is a horizontal asymptote in this graph. So as a new function, totally new function, we have to put 1. Or whatever that is. In this case, the horizontal asymptote is 1. Let's use the standard viewing window by pressing zoom and 6. Here comes the function. Here comes the horizontal asymptote. With these new calculators, my apologies, I have not researched that, why the vertical asymptote does not appear. With the calculators I've been using, the vertical asymptote will always appear. Here it does not. I'm going to look it up and see why the horizontal asymptote does not pop up. But we know it's there, as you see. And the other thing that I forgot, I would like you to tell me the range of this function. My apologies. So here it is. We checked everything with the graphing calculator. So now I need the range. So what is the range of this function? Anyone?
Is it negative infinity 1 union?
Very good. Very good.
Okay.
Thank you very much. Excellent. Great job. Okay, perfect. Any questions here? Okay, let's continue with our rational function type 2. We determined that the domain is anything but 2. Obviously, this function is not defined at 2, and then x equals 2 represents what?
Vertical asymptote.
Very good. Then I know that these must be infinities. I don't know the sign. I will establish the sign with 1.9 and 2.1. The reason I put them up there is because I'm not going to plot that. I only need these two to determine the sign. After that, I can forget about them. So can you please plug in 1.9 and tell me the sign? Just the sign.
Negative.
Yes. Very good. And the sign with 2.1?
Positive.
Very good. Do we all agree with that? Do we agree or disagree?
Agree.
Very good. Okay, very good. So then the next step is to determine the x-intercepts. So the x-intercept, as we know, is f of x equals 0, but 1 over x minus 2 is 0. Can it be 0? It cannot be 0 because 1, which is the numerator, can never be 0. No x-intercepts. Now the y-intercept is a different story. I have to find f of 0. 0, 1 over negative 2 is negative 1/2. 0, negative 1/2. Final step, almost final, before we graph, is the end behavior. But since it's type 2, I don't have to do anything. What is the answer for the end behavior for type 2 forever?
0.
That's it. So the end behavior, y equals 0, is a horizontal asymptote I meant to write. Yes, that's it. A function like this cannot be symmetric. There are rational functions that are symmetric, but I'm going to write that f of negative x will never equal f of x, and it will never equal negative f of x. So not symmetric. And as I promised, it took us like 3 minutes, 4 minutes. So let's graph. When we graph a function with asymptotes, what do we have to graph first?
The vertical asymptote.
Yes, and a horizontal. However, you're right. In this case, it will be an overkill. There is no need. A vertical asymptote at 2. And now let's see what the table is telling us. The table says this. From 0, cross the y-axis at 0, negative 1/2, and go to negative infinity on the left-hand side of the asymptote. From 0, cross, go to negative infinity. From approaching 0, cross at 0, negative 1/2, and just go down to negative infinity. On this side is even easier. This is it. Can anyone give us the range?
Oh, negative infinity to 2.
2.
We're talking about the range. The domain is in the table. We're talking about the range.
Negative infinity to 2,
union 2 to
Careful, careful, careful.
infinity.
Careful, careful. Follow my marker. Where is the gap?
Oh, negative 1/2.
Negative 1/2 is here, but I still have a graph here. Negative
Oh,
1.
negative infinity 0, 0 to infinity.
Oh.
The gap is at 0, where the horizontal asymptote is. Same thing with the previous one. Any questions? There is an exception to both of these functions, and we'll talk about that. But before, I would like to look at some real life situations. And then at type 3. Any questions? Any questions? Okay, I'm looking at the book, page 428. If I need to raise the book on something, let me know, and I will. So I'd like to look at problem 101 on 428. And there is a graph there. Ready? Okay, so here's the graph of a function. Can we see? Let me copy the function before I show you the graph. So the function is f of x, 6.5x squared minus 20.4x plus 234 divided by x squared plus 36. We are given the graph. The graph is already given here. So let's follow the pattern. It drops and comes back, increasing slowly, slowly. Okay. So this function, they say, models the pH level of human mouth. There is no measurement unit for pH, it's just a number. X minutes after a person eats food containing sugar. The graph of this function is shown in the figure. So we have the graph, we have the function. My first question is, what type of function is it? Is it linear? Is it polynomial? Is it absolute value? What type is it? Anyone? What type?
The first type?
Yes, it's type 1, rational function. Okay, what do we know about type 1? It has a specific characteristic.
Same degree in both the numerator and denominator.
Very good. Which means that the horizontal asymptote will be
2.
What is the leading coefficient?
2.
The leading coefficient.
6.5.
What is the leading coefficient?
1.
So what is 6.5 over 1?
6.5.
Yes. Is this clear? Is it clear?
Yeah.
So since it's a type 1, then I have the leading coefficient over the leading coefficient. This is the end behavior and also the horizontal asymptote. Is this true? That time goes by. Is it true that this function gets closer and closer to 6.5?
Yes.
That is the meaning of the horizontal asymptote. Eventually, we say we'll go closer and closer to 6.5. Okay, it says now, part A, use the graph to obtain a reasonable estimate of the pH level of human mouth 42 minutes after a person eats food containing sugar. So here's 42, and then I read the Y value. What is that? So that's part 1. What would you say? "42 minutes after we eat something with sugar in it." What do we get? Should I show the graph again?
A pH of 6.
Excellent. 6 has no measurement unit, it's just a number. Is that okay, everyone? Yes?
Yes.
Part B. After eating sugar, when is the pH level the lowest? So we eat sugar, here's the pH level, and then eventually we'll get closer and closer to 6.5. Again, this is the meaning of the horizontal asymptote. So when is the lowest? How many minutes after?
6.
6 minutes. So after eating sugar, the lowest level would be 6 minutes. And how much is it? So remember when we said, where is the minimum? At 6. How much is it? You have to estimate. How much?
4.8, 4.9.
Perfect. That's fine. Perfect. So minimum at x equals 6 minutes. And f of 6 appears to be 4.8. Great job. Part C. According to the graph, what is the normal pH level of the human mouth? According to the graph, what is the normal human pH level?
$6.5.
Because that's the horizontal asymptote. You see how important this is and how interesting this function, a rational function, it has a minimum and eventually will level off to 6.5. Great job. Part D. We already answered part D, but let's answer it again. What is the what is the equation of the horizontal asymptote associated with this function? Which means what will happen over time? If you'd like to mute your video or I'm sorry, audio, so forgive me, audio. So then I don't hear myself several times in an echo. If you'd like, it's up to you. So what is the horizontal asymptote? Y equals? Y equals? Can anyone give us the horizontal asymptote? What is it? wrote it from the beginning.
6.5.
6.5. And in part E, explain the trend, the function. So looking at the graph, I'm just going to graph it here because you may not have it and may not see it. So the graph looks something like this. It has a minimum at 6 minutes. So it drops drastically. My graph is not at scale. So it drops fast in 6 minutes. It drops to 4.8. And then slowly but surely over a long time, about 66 minutes, it follows the trend of going back to normal. So once we eat sugar now, about more than an hour, it takes the pH level in the mouth to get closer and closer to the normal value of 6.5. Any questions? Would you like to look at another word problem or practice with another graph now?
I have a question.
Yes.
So you said 6 point in the first part. You said 6.5. How we determined y was 6.5 over 1, right?
Yes.
So you use the power. What if the power was 3 for both of them? It's the same thing.
The same thing. As long as it's the same degree over same degree is the same type 1.
Okay, so if the first, say the numerator is third degree and the denominator is a second degree, is it still type 1?
We haven't talked about type 3 yet.
Oh, so that would be type 3.
That would be type 3.
Okay.
So when the numerator has degree 3 and the denominator has degree 2, this is type 3. And we haven't talked about it. We haven't shown any example yet.
Okay.
We only talked about same degree over same degree that has the horizontal asymptote leading coefficient over the leading coefficient. And number 2, we talked about higher degree in the denominator where the horizontal asymptote is 0. We haven't gotten to this one.
Nope. Okay.
Good. Other questions? Very good. As long as it's the same degree over same degree, the degree is not important. The horizontal asymptote will be the leading coefficient over the leading coefficient. So we continue with another graph, or you want to continue with another word problem?
Word problem.
Okay.
Say it again. Another word problem? Very good. Okay, here's the next one. Problem 102. On page 428. These are interesting problems. A drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored. The drug's concentration C of t, this function C of t in milligrams per liter, after t hours is modeled by this. I'm going to copy the function. 5t over t squared plus 1. So C of t, 5t over t squared plus 1. Okay, what type of function is it first? And then in that category, what type it is. So is it radical? Is it quadratic? Is it rational? What is it?
Rational quadratic.
So it's a rational. What type of rational? Is it type 1, type 2, or type 3?
Type 2.
Very good. Because it's type 2, what is the horizontal asymptote?
Y equals 0.
And we hope that. Why do we hope that? Because when we take a medication, we hope that eventually the concentration of that medication in our bloodstream is or gets to
Zero.
exactly. That's what we want. We want to take a medication, but we hope that it will dissipate. It will disappear from our system, because otherwise it will be difficult to cope. Very good. So now let's look. They are giving us the graph. So here's the graph of the function. Let me copy it here before, so we can talk about it, and then we can read from the graph. So here's the graph. You like that, right? So this is time t, and this is C of t, concentration of that product, pharmaceutical product in the system. Okay, part A, use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So they want us to determine C of 3, but they want us to determine it from the graph. Okay, so let's take a look. I don't think you can see this one, and I have my stuff here, and I don't know how to show it to you. Okay, can you see it? So it spikes up, and then slowly but surely goes down to 0. So I'm given 10, 10, 1. No, I'm sorry, 0, 10, 1, 0, 3, 2, 0, 3, 1. So when C is 3, 1, 2, 3, and this is 0 to 3, I will read 1.5. And then we can check with the function. So C of 3 in part A, I read it at 1.5. The measurement unit, I'm looking at the concentration in milligrams per liter. Milligrams per liter. Then in part B, they want us to use the functions equation displayed in the function to determine the concentration. Okay, fine. So we had that C of t was 5t over t squared plus 1. So then C of 3 will be 5 times 3, which is 15. 3 squared is 9 plus 1, which is 10. Indeed, I get the same thing. Milligrams per liter. Any questions so far? Okay, there is a part C, I think. Let's take a look. In part C, use the functions equation to find the horizontal asymptote. We don't need that because we already found it. Describe what this means. We already did that. What does this mean when it comes to the concentration of the drug in the patient's bloodstream as time increases? So you already told me. Can you tell me again what is the horizontal asymptote?
Equals 0.
Yes. Indeed, y equals 0. Why do we hope that this is the case? Because the concentration should decrease. The concentration of the medication in the bloodstream should decrease in time to 0. That's what we expect. and hope for.
Is there ever a
Can you say that again? I couldn't hear you. Say it again.
that
Say it again.
Y would equal
TK, I can't hear you.
is there ever a possibility that Y wouldn't equal 0? My internet is messing up. Don't worry about it.
When it comes to concentration, we hope that they studied these patients. That's how they came up with this function. They studied many patients, and after they gave them the same medication, and then they tested their blood in time to see how much medication they still had in their system. And they realized that unless it's a radioactive substance, which may never ever decay to 0, all the other medications are going away in time. And we really hope so. Because otherwise we would be a walking pharmacy. So we do hope that the concentration goes to 0 in time. So these are interesting problems. What I would like us to do on Wednesday, and I will email everyone. I may start a few minutes late on Wednesday. I hope not. On Wednesday, we're going to look at those exceptions. I told you there was an exception, and also from what we just discussed. And also we will look at type 3, but I will only ask you to do one thing for type 3. And you'll see the difference between type 3 and the other two. Any questions? Is there anything that you would like to go back to? Any questions? Anything? Anything?
So I heard when you asked questions, basically saying would Y equal 0, but I thought when you defined type 2, it was definite that Y would
Yes, absolutely.
always equal 0. Is
Yes.
there a possibility?
Yes, this is type 2.
Y wouldn't
That's
equal
why
0?
they came up with that, and it makes sense because the concentration will diminish in time from the bloodstream, and this is type 2, and the horizontal asymptote must be 0. All these go in sync. Concentration of the medication, we hope it goes away, closer and closer to 0. This is a type 2, and the horizontal asymptote is 0. So all these three go together. Was that what you're asking, TK? I didn't hear very well. Did I?
She's asking if Y wouldn't equal 0, is there ever a chance that
Not for this. This function comes from a study. This comes from a study. That was a result that they observed at the study of the experiment. They took a number of patients, they gave them medication, and they followed them in time over I don't know how many days or months to make sure that the concentration doesn't approach, or not necessarily, just to see, just to observe. And they observed that it goes to 0. That's why they came up with this function. Because this function and the horizontal asymptote go together. They came up with that function, and then they said, okay, that's good. The concentration goes to 0. But if it's not type 2, the concentration will not go to 0. But that's what their observation was. That's how they wrote that function. And this is normally what we would have expected to happen.
Okay, so maybe you worded your question wrong, and I just misinterpreted it wrong. Maybe.
But is it clear now?
Yes, that's fine.
Okay, very good. Anything else?